Hello friends, welcome back to our channel. So in the previous session we have seen how to create the linked list and how to display the nodes of a linked list. And in this session we'll see the insertion operation on linked list. That means how many ways we can insert. That means inserting at the beginning and inserting the element at the end of the linked list and inserting the element at the desired position. Right? So let's start our session. Single linked list. So we'll take one data and then we'll start. So let us take this single linked list, there are only 3 nodes. So the first node will be the 10, 20 and 30. So in the previous session we have seen we have created a class node which is with the 2 variables, one is a data and another one is a next, right? So first we'll see how to insert insertion at beginning. So beginning means, so you can here you can observe this is the head. This is the head. So if you want to insert that one, so first we'll write one definition. Okay, we'll write one definition and we'll take the element. So let it be some new node. New node will be some node of some data. So let us say take some data and this data will be coming from the function call, right? So let us take this data and after getting the data, automatically a node will be created here. So in the previous session we have seen, let it be some 5 and initially the next value will be none, right? Now we have to link this one to this one. That means we have to get the address of this one at this position, okay? So for that purpose, what we have to do, so this is a new node. For example, let us consider the shortening NB, new node at beginning. Okay, new node at beginning. So NB dot, right? So NB dot next is equal to, right, here, self dot head. So this is the first step we have to do. So nb dot next means new dot next. So this is the thing is equal to self dot head. What's the address of this one? 1100. So automatically there is a link and immediately we have to change the head value because the head is the value pointing to the first element. So automatically now the self dot head will be enb. So automatically this head will be removed here and that will be associated here, assigned with this one. So let the thing is 1000, address of this one is 1000, right? So hope you understood. So first create one node. So automatically if you create a node, so we'll get the data and none. So a node will be created and at this position what we have to get the address of current first node. Okay, so before insertion of this new node, this is the first node. So this node address should be linked to the current node, that means a new node, because we are inserting the node at beginning. So this becomes the first one. So automatically how to get this location? So new node, that means nb dot next is equal to, this is the head position, previously this is the head. So self dot head, automatically the address will be goes to here, placed here. So immediately we need to change the head because now this is not the head position because this is the second element. So head should be pointing towards the first position, right? So automatically we are getting self dot head is equal to new node. Automatically head will be pointing towards here, right? A very simple method. So only 3 steps. Sorry, only 2 steps. This is the creation of node and only 2 steps. We have to establish the connection and we have to change the head. That's it. And now we'll see how to insert the element insertion at end. Insertion at end. So here also, first of all, we need to get the data. That means we have to create a new node. So NE, that is a node at end. Okay, NE is equal to create some data. Some data. Let it be. So here also it will be called from the function call. Right. So we'll write each function individually. We'll write a function and we'll call this function with the data. Right. So let it be some 40. Immediately after executing this one, we'll get a node, and here we'll get 40 and here we'll get none. Let it be the position, the address is 1400. Address is 1400. Now this 1400 should be linked to the previous node. Okay, this 1400 should be linked to the previous node. So how to get this previous node? For getting this previous node, we need to travel from first element to the last element, because this is the linked list, right? So we have not established the connection from the last node to the new node. So this is the linked list. So we need to travel from first element to the last element. So in order to travel the first element to last element, and one more thing we need to remember is we should not change the head position. We should not change the head position. So I will take some temporary variable and I will store this head here, so that I can change the temp value from the first position to the last position. Okay, I can change the temp value from the first position to the last position. For that purpose, I will go with while loop, while temp dot next. So unless the temp dot next will become none, it will be rotating. That means iterations, right? So I need to change travel. That means temp is equal to temp dot next. See, first temp dot next. So initially the temp value is here. So first temp dot next. Temp dot next is 1100. That is a non-zero. Non-zero means a true. So it will enter into this loop. Temp is equal to temp dot next. So now temp value will be pointing towards here, temp dot next. Okay, now temp value is 1200. It's again non-zero. Again, this will be moving here in the second iteration. Okay, in the third iteration, it will be moving here because it is again non-zero. Right? Again here, it is a non-zero. Now, temp dot next is none. Here the temp dot next is none. So automatically the control will exit from the loop. It will come out from the loop. So after coming to the loop, now we can write temp dot next, because the temp is at the last position, last node. Temp is pointing towards the last node. Now temp dot next is none, which should be having the position of the new node, that is NE. So automatically the NE address will be stored into temp dot next. So here none will be replaced with 1400. So a link will be established here. Right? So once again I'm saying, so first we need to get the data for the new node, which is to be inserted at the end. So after executing this statement, one node will be created with a data 40 and the next value none. Now we need to travel from first position to the last position. Here in the existing linked list, so after executing this one, we have no connection between the last, that means a new element with the existing element, right? So we need to establish the connection. For establishing the connection itself, we need to travel from first element to the last element. So, and one more thing we need to remember is we should not change the head value. So for that purpose, I am taking some temporary value and I am assigning some head to temporary. So I am just keep on iterating the temporary. So while temp dot next, so temp dot next means 1100. So it is a non-zero. If it is non-zero, automatically it will enter into the loop and the temp will be changed to the next. So it will change to the next node. So this will happen till it reaches to the last element. So whenever it reaches to the last element, now you can observe temp dot next is none here. So before establishing the connection, the temp of last element will be the none. So automatically the control will come out from the loop. So now temp dot next will be the current node. That means new node which is to be inserted at the end. So automatically the 1400 address will be stored in the 30 dot next. This and the last element dot next. Okay. So hope you understood this one. So I will execute the program. Don't worry. So this is a simple thing. So how can we insert the data? How can we insert the data at the end? Right. Now we'll see the last one, that is how can we insert the node at desired position, at the desired position. Right. Now here also we'll take one position. Okay. So here one thing to be remembered is, I will write here itself, position. Position is index. Consider position as an index, and the index starts from 0. Okay, index starts from 0. Now we need to send the data. Okay, so let the index values are 0, 1, 2, 3 and 4. These are the index values, right? Now I need to insert some 25 at index 3. Okay, I need to insert the 25, node 25 at index 3. Index 3 is here, right? Now let us take, so NP, that means a new node at position, is equal to, take the node, some let it be 25, that is a data. Okay, that is a 25. Now 25 should be placed here. So before placing here, so if you place here after, see, so I will write the index values here, 0, 1, 2, 3 and 4. Now after executing this statement, a node is created here. A node is created here with a 25 and with a none. So this is np.data and this is np.next. Okay, it's clear now. I think it's clear. So after executing this one, 25 and none is created. Now we need to change the links. So here instead of 1300, so let it be some 1250. 1250 should be pointing here and this 1300 should be pointing here, because this connection should be like this. Okay, so this is the connection, right? This is the connection. So in the place of 1300 we should get a 1250 and in place of none we have to get the 1300, right? Now so after this one, just we need to travel, again we need to travel from 0 to position -1, because we need to change the next value, right? So temp is equal to self.head. So here also we should not change the head position. So we need to place the head as it is and we go with the temporary variable, and this temporary variable will be keep on moving from 0 to position -1. Now I will change that for I in range of position -1. Position -1. What we have to do? We have to keep on moving. So temp is equal to temp dot next. See, for first iteration I is equal to 0. I is equal to 0. So I is equal to 0 means index. So temp is equal to temp dot next. So here head, here itself a temp. Okay, after executing this statement, the temp will be also pointing towards the first element. Temp is equal to temp dot next. So temp is equal to temp dot next means this one. After first iteration, the temp will be moving towards the first index. Again, see here the position is 3. So range of 2, because position -1. So that means 0, 1. So the last index, it should be excluded. 0 we have changed it to here, and whenever I is equal to 1, again temp is equal to temp dot next. So now again the temp become here, right? So next I becomes 2. So here range of 2, position minus 1, range of 2. So stop. So it will come out from the loop. It will come out from the loop. Now what we have to do? So np dot data is equal to data. So we need to give the data. So here the data means 25, right? So np dot data is equal to 25, and np dot next is equal to temp dot next, because here instead of none we should get a 1300, right? Instead of none we have to get the 1300 here, right? So now temp is pointing towards position minus 1, so for temp dot next should be assigned to new node. So here it will get a 1300. Now what about this one? This address should be get. Okay, now temp dot next is equal to, what is this node? np. So this is a np, right? So np should be here, that is a 1250, right? So temp is equal to self dot head. So we have to travel from first node to the last node. So for that purpose, so we should not change the head. So that's why we are taking some temporary variable, and we are just traveling from 0th position to position minus 1, because at that position we have to insert the 25 at that position. So you just remove this link, because 1250 means it will be pointing towards here, and 1300 means this node will be pointing towards here. So there is no link between this 20 and 30, right? So np dot data, so whenever the temp reaches to the position minus 1, now np dot data is equal to data, that means the 25. np dot next, in this position what should be there? So this value. Okay, so you should not interchange these two statements, because if you interchange these two statements the link will not be established. So before disconnecting the link, we should copy the address of the next node to the new node. So that's why np.next is equal to temp.next. After that we can change the temp.next to the new node address, right? So hope you understood this one. So this is a simple process to change the position, right? So insertion at position. Insertion at position. So this is the logic for insertion at position. So I will execute the program implementing all these three. So that means inserting at the beginning, inserting at the ending, and inserting at the desired position, right? So let's move on to the system. So if you are still having any queries, your doubts will be clarified, right? So let's see the execution. Hello friends. So just now we have seen how to insert the elements into the linked list. That means insertion can be possible at the beginning, insertion at the end, and insertion at the specific position. So we'll see the program for insertion. So let us start with the, first we'll create a few elements into the linked list, and then we'll see. So already in the previous session we have created this one. So we have created the code. That means we have created the node, and then we have created one class for single linked list and the display function in order to display the thing. And also we have created an object for single linked list, and we are just creating the nodes, so different values, right? So just I will copy this one so that the time will be saved. See, so till now we have executed this one. So there are some 4 elements here. Okay, so we'll see, we'll see one more element. So n4 is equal to some node of 50, and this address should be placed at n3.next is equal to n4. right? So we'll get a 50. So total 5 elements are there. Now we'll see the functions. So each and everything is a function, right? So we'll create a first function by inserting at the beginning, right? So here we'll write this one. So define, and I will go with the function insert underscore beginning, right? So here we'll go with the self. The first parameter will be the self, and the next one is the data. So which data should be inserted, right? That will be passed from the function itself. We'll pass from the function. Now we'll create, we'll take the small variables. NB is a node, a new node. So here we'll go with the data. So data is created for the new node, and that data should be inserted at the beginning. So if the data is to be inserted at the beginning, the head will be changed. Okay, the head will be changed, and this will become the second node. That means the address of this existing node should be assigned to this new node dot next, right? So let us take here nb dot next is equal to, what is the current node here? This is the head. This is a head. So self dot head, self dot head, right? Now what is the head now? After inserting the first element, what is the head now? The first element will be the head. So change it to here. So self dot head is equal to nb. Hope you understood this one. Insertion at the beginning. So I am taking the value here. Okay. So L dot insert underscore beginning of, I just want to add 5. I just want to add 5. So if I add a 5, this 5 will placed at here. So automatically the 5 we are passing as a parameter, so that will be stored in data, and this data will be giving as a parameter to the node object. So that means nb, that means a new node will be having the data 5. Now see, if it is a 5, automatically we need to change the head, because previously this is the first element, so head is pointing towards 10. Now I have to change the head to 5. That means nb.next is equal to self.head. So whatever the value pointing towards the head, that will be pointing in the new node.next. Now after inserting 5 will be the first node, so we need to change the head also. So that's why self.head is equal to the new node, right? So now just execute this one, you can get right. See, 5 is inserted here, and again go with one more thing, insert underscore beginning of 3, and execute. 3 will be pointing here, right? So automatically first the element should be changed, the present or a current first value address should be placed at the new value next, and the new value must be the head position, only 2 points, right? So this is how we can insert the value at the beginning. Now we'll see how can we insert the value at the end. Okay, see, for that we'll write the function insert, and the same thing, self and data, will pass the data from the function call. So ne means node at end, node data, this is common. Now what we have to do, so whatever the data we are passing as a parameter, that should be placed here. So now head is at this position. Now the head should be, we have to traverse towards the last one. So that means you can observe, we'll take some temporary value, because the head should not be changed. Okay, we have to travel from the first node to last node. So even though the head should not be changed, the head should be pointing towards the first node. That's why I am taking some temporary value as self.head, right? After taking self.head, so we need to travel from first node to last node. For that I will go with it while temp.next. So for the last node, right? For the last node, temp.next will be none. Okay, so for 40, the temp.next will be the address of 50. For 30, the temp.next will be address of 40. For 20, the temp.next will be address of 30. But for 50, the temp.next will be none. So until it reaches the last element, we need to travel. That means change the temp. Temp is equal to temp.next. So for the first iteration, the temp.next will be 5, second iteration 10, third iteration 20, fourth iteration 30, fifth iteration 40, and the sixth iteration 50. And it will come out from the loop because here the temp.next will be none. So immediately now the position, what is the position here? So temp.next is the last one. Now at that position we need to insert the element. So come out from the loop. So directly go with the temp.next is equal to NE. NE means address of the new node. Address of new node. So automatically the new node will be inserted. So you can observe here after beginning. So L dot insert underscore and we'll go with the 60, right? So execute this one. So we'll get a 60 here. So first the node will be, see, first we are taking the new node and we are taking this temporary variable. So self.head is assigned to temporary variable so that we need to travel from first node to last node. For that we are writing some while. So while temp.next, that means unless it reaches to temp.next, that means a none value, it will be traveling from first index. We are changing the temp is equal to temp.next in for every iteration. So after completion of this loop, the temp value will be pointing towards this 50 because the 50 temp.next is empty. So at that point we are just placing the new value to temp.next. Automatically we'll get the result, right? So again L dot insert underscore end of 70, you'll get a 70, right? So these are the elements now, right? Hope you understood this insertion at the beginning and insertion at end, right? Now we'll go with the third one, that is how to insert the element at the desired position. So we need to give the position and at that position the node should be defined, inserted, right? So we'll go with the same thing. So insert underscore position, here give the self and give the position index value, in which index you have to insert the thing. So let it be, for example, the index value of this one is 0, 1, 2, 3. So here you give the index value where we have to insert the position. So I just want to insert the value at 0, 1, 2, 3, 4, right? So fourth index, I just want to see 0, 1, 2, 3, 4. I just want to give that 25. 25 is the data. Okay, sorry, we have to give position and data, right? Position and data, right? So at the function call we'll write this one. So L dot insert underscore position, what is the thing, 4 comma 25 at the fourth index. Okay, I'm not taking about the position, right? Fourth index I'm going to insert 25. For that purpose it will call here. So automatically the 4 will be pointing towards this position and 25 will be pointing towards this data. Now take the new node n position np, that means a new node at a position is equal to node of data, and also we need to travel from first node to that particular position less than that particular position. So again the same thing, use the temporary variable to store the self.head. Now we can travel the temp value. So we know the number of iterations, right? So then we'll go with the for loop for I in range position -1. So until third position we need to travel because we need to insert the position at fourth one. So we need to travel up to third. So 0, 1, 2, 3 here. So after, for that purpose I am going with the position this one. So just go with the traversal. So temp is equal to temp dot next. So after completion of this loop, the pointer, the temp will be at this position. Now at the next of this 20 should be the address of new node. Okay, now you can observe here. So np.data is equal to data and np.next. Okay, np.next means the new node.next should be this one. Okay, that means the temp.next. Hope you understood this one. So now the temporary value will be here. The temp.next is at 30. That should be placed at new node. So new node.next is equal to temp.next. And now the temp.next, right? Now the temp.next must be the new element. Temp.next must be the new element. So if you first give the temp.next is equal to new element, then it is not possible to link this 30 value, that means address of this 30 element, right? So that's why we need to follow the same order. First we are just giving the data, and in the next we are getting temp.next is saved at np.next. Now the temp.next will be the np value, the new value, right? So now see, let us see 425. I'll execute this one. So let us decrease the size so that, see, you can observe here. So np.next, right? So fourth position 25. Just execute this one. We'll get, see, 3, 5, 10, 20 and 25. Okay, and now 0, 1, 2, 3, 4 and 5. Fifth position and sixth position I need to insert the element. So L dot insert underscore position sixth index with a 35. Execute. You'll get this one: 3, 5, 10, 20, 25, 30, 35, 40, 50, 60 and 70. So here once again I'm saying, don't get confused. Position means not the position. Position is here. I am considering the position as an index value. Whether if you consider the index value from 0, okay, we'll give the position, that means index value and the value, right? So hope you understood this one. So insertion at the beginning, insertion at the end, insertion at the particular position, right? So hope you understood this one. Let's stop here, and in the next session we'll see the delete operation, right? So if you are having any doubt regarding this single linked list creation, display or insertion, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you have really understood my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.